4, 5, and 6 are converting from polar coordinates to rectangular coordinates. This is R, this is the measure of your angle. So if I'm thinking about this, this is R, this would be X and Y. So if I'm looking for X, I would use the cosine because I have the adjacent and the hypotenuse. So I would say that the cosine of theta equals X over R. Solving that for X then, X equals R times the cosine of theta. Same kind of thing with the Y. Here I have the opposite over the hypotenuse, so I would say the sine of theta equals Y over R. So Y is going to equal R times the sine of theta. So I'm just basically going to use those two formulas in order to figure out my rectangular coordinates instead of my polar coordinates. So the X value in my point is going to be R times the cosine of theta. My Y value is going to be R times the cosine, or not the cosine, the sine of theta. So in this case, the R is the -3. That's already there, that first value in my polar coordinate. So I'm going to have -3 times the cosine, and here's my angle, 5 pi over 4. Here I'm going to have -3 times the sine of 5 pi over 4. And once again, I'm just going to use my table that I have. So make sure you have your table handy, and you're just going to look up what is the cosine of 5 pi over 4. 5 pi over 4, I get negative square root of 2 over 2. So I'm going to have -3 times negative square root of 2 over 2. Here, I'm going to have -3 times the sine, which is also negative square root of 2 over 2. So, multiplying this out, a negative times a negative is going to give me a positive 3 square root of 2 over 2. That's going to be my X value. Here again, negative times a negative is a positive 3 square root of 2 over 2. And so my rectangular coordinates, in this case, I get 3 square root of 2 over 2 and 3 square root of 2 over 2. So number 5, again, to find my X value, I'm going to take R times the cosine of theta. To find my Y value, R times the sine of theta. So in this case, this is my R value, this is theta. So I'm going to take 2 times the cosine of -11 pi over 6 and 2 times the sine of -11 pi over 6. Now on our table, we don't have negative measures, so we have to change that to the positive measurement. So if I were at -11 pi over 6, I'm just going to take 2 pi minus 11 pi over 6 and change it to the positive measurement. So 6 times 2 would give me 12 pi over 6 minus 11 pi over 6, which is just pi over 6. So I'm really going to do 2 times the cosine of pi over 6 and 2 times the sine of pi over 6. So looking at my cosine of pi over 6. Pi over 6, my cosine is square root of 3 over 2. So 2 times square root of 3 over 2. And my sine is 1/2. 2 times 1/2. So here the 2's cancel out, I get the square root of 3. Here the 2's cancel out, I get 1. So my coordinates would be square root of 3 and 1. So my rectangular coordinates there, I get the square root of 3, positive 1. And number 6, same kind of thing. X is going to equal R, which is -3, times the cosine of my angle, 2 pi over 3. Y is going to equal -3 times the sine of my angle. In this case, I have a positive angle, so I can just look those up. So -3 times the cosine of 2 pi over 3. 2 pi over 3 would be -1/2. Here I have -3 times the sine of 2 pi over 3, which is the square root of 3 over 2. So here I'm going to have a negative times a negative, a positive 3/2. Here I have a negative times a positive, so I have negative 3 square root of 3 over 2. So my rectangular coordinates, 3/2 goes in for my x value, negative 3 square root of 3 over 2 goes in for my y value. So converting from my polar coordinate to my rectangular coordinate, I'm using the r value, which is your first value, times the cosine of your angle, and then the sine of your angle. If this angle isn't a positive angle between 0 and 2 pi, then you've got to convert it into the equivalent angle between 0 and 2 pi.